So when I think of efficient in math, I think which one is going to work best for this type of problem, as in it's going to be pretty quick. I don't want to waste any time, right? You shouldn't be doing quadratic formula if it would have factored really quick, correct? So which one's not going to take a lot of time? Which one am I not going to waste my time on for this, all right? And then which one is going to give me my result in the easiest way? So we're finding the most efficient method for solving quadratics. Depending on the problem, it could be any one of these, all right? There are going to be situations where you can't factor. Well, then you want to see, can I take the square root real quick, okay? Or, especially with these two, I have kids a lot of times are like, I don't want to complete the square at all. I want to do quadratic formula. Most of y'all mess up more on the quadratic formula than you do completing the square because there's more room to make little math errors, okay? So we're going to talk about when it's most efficient to use what method. On Canvas, I've posted this anchor chart. This usually hangs up in my room. But we're not in our rooms. You guys are at home and I'm at home. So I'm going to go over that anchor chart really quickly. And honestly, we'll just remake it right here real fast. So the first thing you should always check when you're solving a quadratic, and I told you guys this as I taught it to you, is does it factor, okay? You guys are very good at factoring by now. You did it in Math 1. You did it for like 3 weeks with me, all right? So we always want to check factoring first. So I'm going to say 1, does the quadratic equation factor? Okay, if it does, then ding, 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 what method should you use? Factoring, right? So we always want to check factoring first. So if the answer is yes, then we're going to factor, okay? I'm making you guys a flow map for this so you can kind of go different directions. If the answer is no, think back between these other 3 options. So we just went over factoring. Then the next quickest method was the square root method, right? So if it does not, then we want to check, is the quadratic in vertex form, or is the B term missing? All right, so think back to this. When we did the square root method, I told you guys this method will work if it is in vertex form, right? AKA if the B term is missing, if it's in binomial form, something squared, okay? So if the quadratic is in vertex form or the B term is missing, if your answer is yes, then we want to do the square root method. And I'm going to circle these. All right. Now, if it's not in vertex form or we're not missing the B, so the answer would be no, then this is where it gets tricky. And this is where I always have students want to argue, quadratic formula is so much easier. But A, y'all don't remember the formula half the time, which is scary because you have a song to remember it. Or B, like I said, you guys will make careless mistakes on all the math inside the formula. So actually the next quickest or easiest for most of you is going to be to check for completing the square, okay? So when we're completing the square, you want to check for 2 things. Is A equal to 1? Or I missed a part. See, I make mistakes too. Is A equal to 1 and B is even? Or is B divisible by A and still even. And we will talk about why this is important, okay? But this is what you want to check next. So if your answer to this is yes, then this is when you would complete the square. Okay? If your answer to this is no, then the only other method that's an option is quadratic formula. All right, so I'm not going to explain this right now because the words aren't really going to mean anything to most of you. I just need to do some examples. This is your anchor chart. Again, I posted it on Canvas if you just want to print that one or copy it, but make sure you have this down on page 4, okay? So I'm going to go ahead and flip to a new sheet, and we're just going to start off with some examples. All right, so let's do example 1. This is your quadratic. All right, so for this example, I asked you to solve. So we're trying to find the x-intercepts, okay? So for this one, first thing you always want to check is what? What's the fastest way between all of our 4 methods? Which one's the fastest? I'll put the list up here for you guys. Factoring, right? It says, does the quadratic factor? If it's yes, that's what we're going to use. If it's no, we're going to try square root method. If that doesn't work, then we're going to try completing the square or quadratic formula, okay? So let's see if number 1 will factor. All right, so I'm looking for factors of my first term and my last term because it's a trinomial. Make sure, and I'm talking to Amari and my other people out there that are always like, crap, I forgot to check Carson. Make sure you take out a GCF first, okay? If there is one. 3 does not go into 5, so there's no GCF. So factors of 3 are 3 and 1. Factors of 8 could be 8 and 1 or 4 and 2, all right? So we're going to split this up, 3x and 1x. And then remember, we usually try the ones that are closest together first. So we're going to try 4 and 2, okay? So I'm going to FOIL this out in my head real quick. That part doesn't even matter. We're looking for our middle numbers. 3 times 2 is 6. 4 times 1 is 4. Does 6 and 4 make 5? No. And that's for adding, so that's my fault. We're subtracting. Does 6 minus 4 make 5? No, it makes 2. So that doesn't work. So let's try the 2 here and the 4 here. 3 times 4 is 12. 2 times 1 is 2. Does 12 minus 2 give us 5? No, it gives us 10. So 4 and 2 do not work. Okay? So now let's try 8 and 1. Daisy, no ma'am. All right, 3 times 1 is 3. 8 times 1 is 8. If I do 8 minus 3, do I get 5? Yes, and if I want the 5 to be negative, then my 8 is going to be negative, and my 1 is going to be positive. So this does factor, which means the most efficient method was by factoring, okay? So remember, once you get here, to find your x-intercepts, we're just going to set each factor equal to 0, because if it's an x-intercept, that means that the x value is going to be, or the y value is going to be sitting at 0. So I'm going to add 8 to the other side. 3x equals 8, divide by 3, and x will equal 8/3, which means the x-intercept is at 8/3, 0. Okay, and then for this one, you would subtract the 1 over, so x would be at -1, which means the other x-intercept is at -1, 0. All right, now on your assessment on Wednesday, and I think on your homework tonight as well, you're gonna have to tell me what the most efficient method was and why. So this would be factoring. Because the quadratic factors, okay? Factoring is your quickest method, and it will factor. So that is why factoring is the most efficient. All right, we should be good with number 1. So let's try number 2. (4x squared minus 208 equals f of x). All right, so if we look at example 2, first thing we would normally always try, and I did say normally for a reason, so I don't want anybody to freak out yet, but the first thing we would normally always try is to factor. However, I see something very noticeable about this quadratic. What's missing? Good, so this one does not have a b term, right? Okay, look at your anchor chart. Is it in vertex form, or is the b term missing? You guys know that if there's no b, then I can add the 208 over to the other side. Set this equal to 0 because we're finding the x-intercepts, right? So 4x squared equals 0 plus 208 is 208. And now if I can get this x squared by itself, then all I have to do is take the square root of both sides. So even if this one would factor, which it doesn't, but even if it would, the most efficient method here is going to be taking the square root really quick because the b term is missing, okay? So I'm going to divide the 4. We get x squared equals 52. All right. And then once you get x squared by itself, you can take the square root of both sides. And we've learned that if we have to take the square root of both sides, you can get a positive answer or a negative one, right? So this is plus or minus square root of 52. And then the last thing you have to do is simplify. And this is where my kiddos, you are messing up on this. And this is not good because we did this in unit 2. So I need you to really make sure you listen to what I'm saying in this video, okay? To simplify this radical, I want to find the biggest perfect square that goes into 52. So my options are 4, 9, 16, 25, 36. I know 36 isn't going to work because if you do 52 divided by 2, you get 26, right? So let's see if 52 divides by 16. Didn't work, right? So let's try the next biggest one. 52 divided by 9. Didn't work. 52 divided by 4, we get 13. So look at this. This breaks down into the square root of 4 times the square root of 13. And then we know the square root of 4 is just a whole 2. So this means that we get positive 2 square root of 13 comma 0 and negative 2 square root of 13 comma 0 as our x-intercepts.